This is the video introduction for the acid-base chemistry lesson plan. It was created by Justin Wiseman and edited and narrated by Sean Krupa. This video and accompanying lesson plan are part of Ohio University's Boat of Knowledge in the Science Classroom, funded by the National Science Foundation. How many of you are familiar with what's shown in the picture on the screen? If you answered that this is a vinegar baking soda volcano, you're correct. And for some of you, this may have been your very first chemistry experiment. But what if there was another way to talk about the chemistry going on inside this volcano? Let's talk about acids and bases, the topic of this lesson plan. At this point, it's assumed that the students have at least an elementary understanding of acids and bases. If not, it's encouraged that they first view the more thorough introduction provided in the YouTube link below. So, what are acids and bases? A well-accepted definition of acids and bases comes from Bronsted and Lowry. Their definition is based on the mechanism of the reactions. An acid is said to be a proton donor, while a base is a proton acceptor. Remember that a proton is the same as one hydrogen ion, that's one hydrogen atom with its electron removed. In this way, we can see that when an acid is combined with a base, donors and acceptors combine, and the mixture begins to neutralize. Now let's talk about acid-base reactions. In general, when you combine a strong acid with a strong base, this results in the formation of water and a salt. Here's an example. When you combine hydrochloric acid with sodium hydroxide, the result is water plus NaCl or sodium chloride. We know this as table salt. Here's another slightly more complicated example. Can you guess which reaction this is? This is our vinegar baking soda reaction. It looks a little bit more complicated because there's an intermediate step. Now let's talk about pH and the pH scale. pH is defined as the negative logarithm of the hydrogen concentration. The pH scale indicates how acidic something is. The smaller the number on the pH scale, the more acidic something is, and the higher the number, the less acidic it is. Here are some notes. On the pH scale, 7 is defined as neutral. Therefore, anything with a pH less than 7 is said to be acidic, while anything with a pH greater than 7 is said to be basic. Most liquids will fall somewhere between 0 and 14 on the pH scale. However, it's important to note that there's no upper or lower bound. Finally, the pH scale is a logarithmic scale based on the definition of pH. Therefore, if you decrease by one number on the pH scale, that's equivalent to becoming 10 times more acidic. Let's do a quick example to test our understanding of pH and the pH scale. How much more acidic is vinegar than seawater? Take a few minutes and use the pH scale to answer this question. You can pause this video now until you're ready to hear the solution. Here's the solution. The pH of vinegar is 3, while the pH of seawater is 8, and the difference of 8 and 3 is 5. But remember, we said that decreasing by one number on the pH scale was equivalent to becoming 10 times more acidic. Therefore, a decrease of 5 is really 5 orders of magnitude more acidic, or 10 to the 5th times more acidic. Therefore, vinegar is 100,000 times more acidic than seawater. We're now ready to perform a pH activity. The goal of this activity is to test the pH of several common fluids. Here are the materials that you'll need: pH indicator, several household fluids, a test tube or small container for each fluid, a dropper or pipette, and paper strips, which are optional. To start, you're going to need some pH indicator. This can be made at home using red cabbage. You can make the pH indicator as an expansion to this activity, or, in the interest of time, the teacher can create the pH indicator ahead of time. Here are the instructions for making pH indicator. Begin the activity by filling test tubes or the small containers with a small amount of the pH indicator. Note the initial color. As a control, you can add a few drops of the same water that was used to create the pH indicator. The color should not change. You'll need as many containers as liquids you wish to test. Make a prediction about what's going to happen before you add each liquid. Then, slowly add the test substance a few drops at a time. Notice the color change and record. Repeat this for each liquid you want to test. Make observations after each test. Here's the pH scale, except this time it's shown as colors based on the reaction with the pH indicator made from red cabbage. Using the pH scale with red cabbage indicator, try to guess which liquids these are. You can choose 4 of the 5 in the green box. Pause this video until you're ready to see the solution. From left to right, they are vinegar, cola, dish soap, and laundry soap. At this point, you can try as many liquids as you want. If you're going to use cola, it's recommended that you use a clear cola and not a dark colored cola. An optional addition to this activity is to create homemade litmus paper. This can be done simply by cutting regular paper into strips and submerging in the red cabbage pH indicator. You want to make sure that your strips are completely submerged. They should look like the strips in the bottom right corner. After they're completely saturated, take them out and put them on a tray or a rack to dry overnight until they're completely dry. When you're ready to use your litmus paper, simply dip it into a small container or vial filled with the substance you wish to test. Now, this time, the litmus paper's color will change. Again, make observations, predictions, and record each time you test something. Here are some take-home points. Acid-base reactions represent many of the chemical reactions we see every day. We defined acids and bases according to the Bronsted-Lowry definitions. An acid is a proton donor, while a base is a proton acceptor. Remember that the pH scale is used to show how acidic something is, and that the pH scale is a logarithmic scale. Finally, we did an activity where we used red cabbage as a pH indicator to test the pH of several common fluids. This concludes the video introduction for the acid-base chemistry lesson plan. Thanks for your attention.